Far more than ever before, location information plays an important role in almost every aspect of our lives. Many times each day, whether during our work or leisure activities, our position in the landscape will have a direct impact on the services we access, the way we move around, and the choices we make. Increasingly, where things are spatially is very important, and given this importance, it is now vital that we are able to visualize where different features occur in a landscape, how they interact with each other, and how they are connected together. So how do we make sense of this hugely diverse and highly complex spatial information? Well, the first thing we do is to simplify the process by breaking the real world down into layers. Each layer, which can represent point locations, areas, or networks of lines, is used to represent just one set of features in a landscape. Once created, these layers of spatial data can then be combined together, interpreted, analysed, or visualised to create the geographic information we need to make sense of the world around us. Take an Ordnance Survey map of southwest England as an example. Even this simple map, which is designed to be used as a navigational aid, illustrates how complex the myriad of features in our landscape can become when they are overlaid. What's clever about this map is that despite the complexity of the data shown, by dividing the features into different types and representing them in different ways, its creator has still managed to create a powerful, visually striking and easy to interpret piece of geographic information. So to understand our landscapes, how they work, and perhaps most importantly, how we should manage them, we need a way to visualize and explore the spatial relationships between their different component parts, and in so doing, generate the geographic information, the evidence, that we need. The way we do this is to use a tool called a Geographic Information System, or GIS. A GIS allows us to break the real world down into layers. And having done this, it then allows us to analyse data visually and see patterns, trends and relationships that are not easily recognisable in a table or written as words. As an environmental professional, we will often visit a specific location, a river, a farm or a natural habitat to study it. We want to learn about its character or its condition. We can actually learn a lot about a place by visiting it. We can measure the chemical composition or physical properties of the environment, or we can record the species that we observe, or the structure of the surrounding habitat. But there are also many questions about a location that we cannot answer by simply going to it. For example, we can't see how it fits into the wider landscape. We can't see its size, its shape. We can't see the composition of the surrounding area. And perhaps most importantly, we can't see how it is connected to other similar locations nearby. Using a GIS, we can answer these questions. In a GIS, we create spatial data to graphically represent the features in the landscape. And then we can also record additional information about them, referred to as attributes. By placing the features into a measured grid, we can go further and determine the size, shape and orientation of the different elements. We can also begin to visualize how different elements of the landscape are connected together, and so we can begin to gain an insight into how the ecosystem is functioning. So what exactly is a geographic information system? Well, a GIS is actually comprised of 4 critical components. The first 3 of these are a computer, a software application, and a collection of spatial data, while the 4th and perhaps most important component is the user. It is the user who needs to answer a spatial question, to produce some spatial evidence, or to communicate a spatial message. And it is the user who has recognised that a GIS is the right tool to achieve this objective. Before someone can become a skilled user of GIS, it is of course vital that they develop a technical understanding of spatial data and how a GIS application can be used to interpret and interrogate that data. However, before these technical skills can be used, it is perhaps even more important that they first learn about the different ways a GIS can be used to produce different types of geographic information. Otherwise, how can they recognise when GIS is the tool they need to use? The application of GIS falls into 3 broad categories: A GIS provides us with a powerful tool for the creation and management of spatial data. A GIS allows us to answer spatial questions and to perform spatial analyses on the data. And third, it can also be used to communicate geographic information through the production of maps. Each one of these applications is equally important, and each has made GIS an indispensable tool for people working in the environmental, land management, conservation, and ecological sectors. Using GIS, we can record and collate the environmental data that we have collected, report our activities, and show the distribution or coverage of the work we have delivered. We can use GIS to answer spatial questions and to perform spatial analyses to gain even further insights into the structure and function of our natural landscapes. The outputs of these analyses can be used to develop our conservation strategy, to identify areas of heightened opportunity or risk, and to target our actions more effectively and with greater chance of success. Finally, the maps we produce with our GIS can also help us to communicate a wide variety of environmental messages to an array of different audiences. Whether the message is simple or highly complex, a map can help us to engage the public, local stakeholders, policymakers, and the wider scientific community in a clear and effective manner. For more information about the use of GIS in ecology, conservation and environmental management, or to begin learning how to use GIS for your work, please visit the EcoSpatial GIS training website.